All right, and welcome to the October update, where we tell you all about what happened in September from the development team. So without further ado, I'm going to pass it on to Karim for his overview this month.
Thank you, Fala, and welcome everybody. On this month, on the Agoras side, on the Agoras Live side, Andre has added the ability to search for public sessions and continue testing the service for getting ready for a final release fairly soon. He continued fixing a few minor issues and optimizations on the back end. So Agoras Live is getting really close to potential release here. On the TML side, we're also in release mode. We're pretty much feature complete. We're putting the final touches on all the features, and we're benchmarking and QAing all those features that will be put into TML 1.0. In particular, Luca continued working on the 2CNF extraction. He revised the extraction function to extract 2CNFs from BDDs while they're being built, and the ability to merge 2CNFs back into BDDs while maintaining the canonicity of BDDs, which is a very important properties for BDDs. Maurici, as we talked about last month, did a great job implementing the proof of extraction feature, or proof tree extraction. And so this month he continued testing that, and he optimized it and fixed a few bugs with it. He also added flags to allow the user to specify what kind of proof they want. He also implemented another major feature this month, which is variable shifters in BDDs, which are supposed to save a lot of memory usage for BDDs, not necessarily save execution time, but save memory usage for BDDs. So we went over that implementation. Everybody, both Ahad and Juan, reviewed his code on variable shifters, and it's being tested right now before inclusion in the final release, TML in the 1.0 release, that is. He also fixed the dead variable elimination in the presence of deletion rules, which is one minor feature that he hadn't gotten into in the first implementation. And he also updated the eval predicate in the presence of proof trees. Juan, as I mentioned earlier, was very instrumental in assisting both Maurici and Omar in their tasks, but he also wrapped up the major implementation that he did with second order logic. And he has also been running benchmarks for TML in preparation for the release and comparing them with the performance of other programming languages. And finally, Tomasz has been also testing the proof extraction feature that Maurici implemented last month, and he's been working on integrating that into the TML IDE. He's got some good ideas around that. He also continued his work on state blocks, which should make TML easier to program with. And also for the IDE, he's working on making REPL work within the TML IDE, which make the IDE itself much more useful to use. That's it on the TML side. So we're hoping to get a TML 1.0 release for sure by the end of this month, this year. But we're very much concerned with performance and quality, basically, of the software. That's our number one criteria, not necessarily an expedient release.
Excellent. Thank you very much, Karim, for your overview. All right, I'd like to introduce you to a member of our team who's been here, but we haven't been able to make him public. His name is Dr. Kramer. And yeah, I'll pass it over to Dr. Kramer to introduce himself.
I have been participating in the meetings of the developer team now already for some months. Christoph already gave a very good overview of what we did. And so one of the focus points recently has been trying to develop a logical language that users of the system can use in order to input information into the system. And the focus there was on the problem of, well, that this in this logical language, users should also be able, among many other things, to input information about how the system itself should function, how future versions of the system should function. It should be possible to make proposals about this, to debate proposals about this within the logical language of the system. And one issue that we have encountered when trying to do this was that, well, when you have a logical language that basically can talk about itself, that's what we can want here. It's a self-referential thing that within the language you can talk about how the system should work, and the system itself uses that language. With this kind of self-referentiality, there is a risk, if one doesn't set it up very carefully, that one allows for certain kinds of paradoxes that are kind of similar in nature to the famous liar paradox, where one can say this sentence is false, or this sentence is not true. And if you try to analyze if you think it's true, then you conclude it's not true. If you think it's not true, you conclude it's true. So either way, you get into a problem. And basically, we have a bit of a similar issue about how we define the language that underlies the tau system, because it has to have certain capacities of self-reference in order for users to be able to talk about the tau system within the tau system. But at the same time, it has to, well, either completely avoid the possibility of writing down paradoxical sentences, or have some way of handling them in case people do write them down. Yes, so we're still actually in the process of considering various options here of how precisely to handle this problem. There was a proposal by Ohad, there was a proposal by myself, and actually multiple proposals from each side, and we're constantly improving on this, and have already got much more clarity on what precisely we require for the system. But yes, this has been one of these things where we realized we need a bit more. We need to put quite a lot of careful thought into this in order to make this basic functioning of the system well defined. I think that's it from my side for the moment.
Thank you very much, Dr. Karama. Great to hear from you. Great to have you publicly visible as part of the team. And I will now pass it over to Professor Benzema for his update this month.
Thank you very much. Yeah, we can leave away the professor here. Well, yeah, we had, of course, continuation of the panel discussions, the academic panel discussions. Here we dived into a proposal by Marcos Karama. I think he will talk himself a bit about it, and compared it then also with Ohad's proposal. So the discussion on that end is still not completely finalized, I would say, but we have made there very good further insights by this alternative view. Recently, we also dived into a discussion of one of the opening questions now, how to handle actually side effects. We looked into a proposal in particular by Enrico Franconi, where he pointed us to the situation calculus to model and reason with side effects, with states essentially. And the alternative, the alternative we are looking into that is, of course, functional programming and eventually a dependently typed infrastructure behind it. Well, I don't dive too much here into the panel discussions. We will probably hear more about from the two other participants there. On the other side, as listeners here might know, I'm very much active in the development of an external team improver that's also exploring concurrency and sequential team improving. It's a Tableau-based prover. I've made further progress here. In last month's sessions, we discovered first a bug that was an interesting one. It was related to how to deal appropriately, correctly with 3 variables in the Tableau. So the Tableau reason I am building is actually a 3 variable Tableau system. And that means I have to take into account that I do maximum matchings on branches, which I didn't do in the previous version. And that is fixed now. Today we had a presentation in which I then showed the test example we are looking at currently together, also with the development group of the other provers in the TML side. And I demonstrated that the models I can get. I also demonstrated how you can debug the team proving systems in comparison to what the TPTP infrastructure provides, namely a bunch of different team proving systems and model finders. And in my team prover, I, for instance, have provided now an output that I can directly use as an input to those systems so that I can directly compare their responses to my own ones. I have mentioned that this could be a general direction to set up a testing infrastructure for us. So a big library of examples with runs then over our own team provers and compare them mutually against each other. And in addition to compare them with the external systems as available on TPTP. So that could be an interesting future work to automate that. What I do at the moment when debugging, they're often still by hand. So on that side, I think we have now nice and fruitful meetings in which we mutually inform each other about team proving processes and insights in the techniques there. And I think that is much needed in order to early detect errors and, let's say, not so fruitful directions. So to prevent, let's say, erroneous programming from the beginning, communication here is very essential. And I think with our weekly meetings, we have a good setup there. I think that's enough. I've talked already way too much. Thank you.
All right, Professor Benzema, thank you so much. I will now pass it over to Omar for his update this month.
Hi team, glad to see you all. So this month of September, we have been working on making changes to the arithmetic and basically non-relational raw terms for bit universe transformation. So previously they were not being handled. Now we have converted nearly all of the non-relation terms into relational terms in bit universe. So that allows a concise and standard way and format of representing any raw program in bit universe. Secondly, we also added type checker for the fall terms, which are first order logic terms. We did have a type checker for the basic raw terms, but for structures like first order formula that have raw terms at the leaf level, we needed to do type check them as well. And having done so, that enables us to transform any raw first order formula into its corresponding bit universe transformation. We also added some basic tests for type checking and type inference. Also, it was nice to have a standard representation for arithmetic terms in the bit universe. So now everything is actually a predicate there. So that has been what we have been working in the month of September. There was also some discussions and design considerations of how to implement and consider different options regarding bit universe transformations for arithmetic terms and so on, and how we transform and carry that information that we have at the type information level down to the BDDs in an efficient and concise way. So we have different paths there, and we are just trying to figure out what is the best way to take it down to the BDD levels. Thank you. Bye.
All right, Omar, thank you so much for your update there. Really cool stuff, as always. I'll pass it over to Andre for his update this month. Cheers.
Hello, everyone. Finally, with Agoras Live, we reach the point where I'm not adding any features, only small feature of searching among public sessions, but it's small. And I concentrated all my efforts on finding and fixing all issues I may find, and on refactoring front-end and back-end code to be able to quickly find and resolve all issues that we plan to find with the quality assurance engineer we're looking to hire to help me on this side. And I'm looking forward to the next months where I hopefully can, along with this engineer, wrap up the testing phase of Agoras Live and release it to some beta testers prior to final release. So that's pretty much it for this month. Thank you.
Excellent. Thank you very much, Andre. And I'll now pass it on to Juan for his update this month.
Hi, Fola, and hi, everybody. Thanks. Yes, as Karim put into advance, I did relevant progress on the second order logic feature, monadic second order feature. I always put that for clear. And where we are heading right now is to have this interval based representation for the second order variables, or dual constraint based representation for the second order variables roughly in place. We still have the issues to solve at the algebraic level and also on the implementation level, but the overall approach is at this point more or less confirmed. So I think we're on the right track there. So we did some revision with the development team, and yeah, OHA quickly point out an aspect of the current implementation, current design that is not being considered, which accounts to the constraining, the constraint of second order variables where they have mutual dependencies. So that's something I'm still under consideration, under design, but I'm positive that we will also be able to handle that as well. So the current implementation is still under design. It's a very raw prototype, but we need to keep working on it. But it is, as I mentioned before, it is a possible path to the final solution, and yeah, and it's not a major milestone what we accomplished this month, but at least it's the confirmation that much of what it has been said so far for the last couple of months, it is a decent way to attack the problem. So that I will leave that by now in that in this description. And I also have been testing TML on different aspects. First of the logic, and we got some interesting benchmark related to batch transfers that allow us to compare TML versus Python implementation and C/C++ implementation, showing some very interesting number for TML. Of course, we observed that we were able to process a batch transfer operation faster than Python. Of course, we are not faster than C, but we were able to handle a data set with a database with 100 million entries, and one of the most relevant points to highlight is the memory requirements for TML, while for C it's a memory allocation of several hundreds of megabytes. In TML, we can represent that information. It's just a few less than a megabyte or a few Ks. So in terms of data compression, TML is showing really powerful capabilities. And also this benchmark allowed us to identify some of our performance bottlenecks with regards to arithmetic features. And so I have been also shifting my attention into redesign some very let's say deep details of TML in order to take advantage of our most advanced arithmetic features that should be able to really tackle this bottleneck in the short term. But again, preliminary thoughts, preliminary information, but we are on that focus. Get faster arithmetic in order to handle these huge databases in an efficient way. So this is all from my side today. Thanks.
Brilliant. Thank you very much, Juan. There's so many members of the team left. Let's get Luca to give us his update this month.
Thank you very much, Fola. Hello, everyone. So this month, I continued working on my implementation of the 2CNF extraction. My last update, I mentioned that I had laid out the main routines on how to do this, and during this month, I actually implemented it, and I managed to finish the merge function, which essentially combines two 2CNFs coming from a high and a low node in the BDD node, combining them to the parent node, so to speak. I was also able to finish the add function, which retrieves 2CNFs from the BDDs during the build of a BDD. And currently I'm working on canonicity aspects when getting those specially represented BDD nodes in memory back to the BDD level, because we have to preserve canonicity. This has been a challenge, and I'm making progress and hopefully get the feature finished within the next month. And yeah, when this is done, we are looking into ways how we can make the best use of this abstraction, and this will hopefully speed up TML even more, and I'm very excited for this to come. So thank you very much, and I'll pass this back to Fola.
All right, excellent. Thank you very much, Luca. I'll pass it to Maurici for his update this month.
So this month, I improved the performance of proof trees by changing how they're done internally. And now I've given some flags or some options to control the generation of proof trees. And this will allow people to select whether they just want one tree, which is just one proof that affect one proof of how a fact is derived. Or you can also ask for a forest, which gives all the proofs. I also added some additional options about partial proofs, where it tries to filter out some detail, which might not be so desired by the user. But you can also get a complete proof if you want the entire proof, although it's much larger and a bit harder to process. And I've also added the option, I've also enabled negative facts to be proven. So you can actually prove that this fact couldn't have been derived at a particular point during the execution of a TML program. Another thing which I've done this month is I have implemented variable shifting for BDDs and tested it and benchmarked it against the existing shifterless implementation. This is still kind of in progress. I've given it off to the team, and they've reviewed it, and they've given me some feedback. So I hope to be addressing it during the coming month. But from what I've seen so far, it does reduce memory usage, and sometimes quite significantly, like up to 30%. Although the performance does lag to different degrees. But I'm sure that with further tuning, I can also get the performance to improve on more cases. And also another thing which I did this month was just I prototyped a small resolution propositional theorem prover in TML using the proof tree functionality which I was working on last month. So now you can so basically just with this, it's not it's a prototype, but essentially it just shows that you can use TML to prove various propositional theorems, and using the proof tree functionality will give you like the sorts of rules that were used to derive a particular contradiction. And I believe that this should be extendable to maybe quantifier-free formulas with predicates in them. Although I'm seeing that if you try and get the entirety of first-order logic, you may run into some difficulties and some trade-offs, which is similar to those encountered during implementation of eval. And the other thing which I was working on this month was just fixing dead variable elimination. There was a bit of a bug when it was working on deletion rules, but it's now resolved. And yeah, as Karen mentioned, I was also updating eval to provide condensed outputs. I did this mostly by filtering out details which I believed were less relevant to users, and just keeping the critical detail. And in doing this, I was also able to yield shorter proof trees. I was able to yield shorter proof trees by simplifying the process by which eval works. So now it's easier to kind of see how eval is deriving certain facts. And yes, that's my progress for this month. Thank you.
All right, thank you very much, Maurice. All right, I'll pass it over to Tomasz for his update this month.
Thank you, Fola. Hello, everyone. In September, I worked on state blocks syntax transformation, which should be finished in following days. I've continued work on making TML's REPL feature work in JavaScript build, so it's available in the IDE as well. Currently, I'm solving an issue with threads library. I was getting familiar with the fixed proof extraction by Maurice, and I'm preparing an integration of proof trees into the IDE. And also I've been addressing JavaScript build scripts, so TML does not work only in a browser, but also in a Node.js environment. So that's all from me this month. Thank you.
Brilliant, thanks so much. And Ahad, I hope you're doing well. Last but not least, let's get on to your update.
So aside being involved in almost everything you hear here, I also continued later with the implementation of the early parser, which will replace the parser component in TML. And also in the logical language that we are considering, to consider aspects of self-reference, as Marcus explained before. And also, as Christoph explained before, how to turn those logics into programming language or specification languages mainly. While the main missing component is how to treat side effects as for themselves, and also without breaking the nice logical properties that we managed to achieve. And that's basically all.
All right, thank you very much, Ahad. Team, it's great to see you. Community, it's great to see you too. Thank you very much for tuning into this development update, and we will see you in Telegram. Cheers.